Welcome to a series of lessons looking at trigonometry. I'm your presenter today, Aaron Lewis. In this series of lessons, we'll be looking at right-angled triangle trigonometry, using the sine rule, using the cosine rule, calculating the area of triangles and problem solving, graphs of trigonometric functions. In this lesson, we are going to be calculating the area of triangles and problem solving. In this lesson, you're going to learn how to calculate the area of a triangle when given an angle and two side lengths. This will include using your calculator. This lesson is suitable for a student who will be taking A-level maths. The language of this lesson is English, and this lesson should last around 30 minutes. The learning aims of this lesson are to be able to calculate the area of a triangle and to be able to apply different formulae to problem solving questions. As in the two previous videos, the first step is to label triangles correctly. I'm going to use the same labeling technique that was used in this sine video and cosine video. First thing I'm going to do is label this side lowercase a, which means the opposite angle is capital A. This side is lowercase b, which means the opposite angle is uppercase B. This side is lowercase c, which means the opposite angle is capital C. And the example beneath, this side is lowercase a, which means the opposite angle is uppercase A. This side is B, which means the opposite angle is uppercase B. This angle would be uppercase C, which means that this side is lowercase c. As in the two previous videos, all that matters is that the opposite side has the same letter but a different case. So the formula for the area of a triangle when we're not given the height is a half a multiplied by b multiplied by sine c. So for this triangle on the left here, we are not given the height, but we could calculate the area by following that formula. Now this formula can be written slightly differently. It can be written as a half BC sine A, or a half AC sine B. And what's important to notice, if you look at this first formula here, is a half AB sine C. And looking at this problem, that would be AB sine C. So just like the cosine rule, it's two sides and the angle between them. Let's look at the second formula, BC sine A. Looking at this bottom triangle, BC sine A. So two sides of the angle between, just like the cosine rule. Here is our first example. Using the area is equal to half AB sine C, can the area of the following triangle be calculated without using another formula? So all I'm looking for is two sides and the angle between. And hopefully you can see that here. So first of all, I'm going to jot the formula, half AB sine C. So we're looking for two sides and the angle between. So the 30-degree angle is going to be capital C. A will be equal to 10 and B will be equal to 4. Now A and B are interchangeable. So in this case here, can the area be calculated without using another formula? The answer is yes, it can. Here is your question. Pause the video and have a go now. Okay, let's have a look. We're looking for two sides and an angle between, which looks like these two. So therefore the 56 is capital C. A could be 12 and B could be 15. So yes, we could calculate the area. Next problem. Same thing again. Using a half AB sine C, can the area be calculated without using another formula? Looking at this problem, I've got lots of sides, but no angle in between. So I couldn't be able to do it. I would need to use possibly the cosine rule to find out an angle. Here's your question. Pause the video and have a go now. So we've definitely got two sides, but we don't have an angle between. So in this case here, no, it can't be done just by using the formula. This left-hand side one, we would need to use the cosine rule to find an angle. On this right-hand side one here, we'd not like to calculate this angle here, but we'd need to be able to calculate this one as well, so we'd need to use the sine rule. And then the sum of the angles of a triangle is 180 degrees. What I'd like to do is pause the video, have a go at mini quiz 1 and press play when you're finished. So in the following problems, we're going to be finding the area. The first step is to identify and label the sides. So in this problem, I'm looking for two sides and an angle between. And there it is. Two sides and the angle between. So if I'm using a half AB sine C, or a half BC sine A, or a half AC sine B, which are all equivalent, it wouldn't matter. So I'm going to call 50 capital C, lowercase a I'm going to call 5, and lowercase b I'm going to call 8. Now it doesn't matter which way those are written, because we're going to be multiplying by them. There's the formula. There's the substitution. Typing that into my calculator and pressing equals gives me 15.32 square centimetres. Here is your question. Pause the video and have a go now. Here is the solution. Two sides and the angle between. And there we go. The area is 25.71 square centimetres. Here's another problem. So I'm asked to find the area of this triangle. I'm looking for two sides and the angle between. At the minute I can't see that. It's not happening here, happening here, or happening here. But I can work out this missing angle here. 50 plus 30 is 80, which means this missing angle is 100 degrees. And now I have the relevant parts for the area. So capital C is going to be 100. Lowercase a is either going to be 10 or 4. And lowercase b is going to be the same. And there is the labelling. So just watch out for those problems where you just need to find one missing angle. And so the area comes out as 19.7. Here is your problem. Pause the video and have a go now. Here is the solution. So this angle here is 12 degrees. So it's a half multiplied by 12 multiplied by 15 multiplied by sine 12, which is 18.71 square centimetres. Pause the video, have a go at mini quiz 2 and press play when you're ready. Here are the final examples, and this is applying formulae to solve problems. So in the following problems we might need to use the sine rule, use the cosine rule, and the formula for the area of a triangle to calculate. So in this question we're asked to find the area of this triangle here. Now we need two sides and the angle between. First step is to label the sides. So what I've decided to do is call that top angle capital A, call 10 lowercase a, the 20 centimetre side is B, the opposite angle is capital B, the 11 centimetre side is lowercase c, and the opposite angle is capital C. So remember from the previous video, if we need to find an angle, we are using the cosine rule. That is the formula we need to use, and I just need to identify the relevant pieces. So I'm going to try and find this angle here. So lowercase a is going to be 10. And we'd love to work out what capital A is. So I've got B as 20 and C as 11. So that's a revision there of the cosine rule. Noticing that the x here should be an x. I'll call that angle up there x. Should have been an A. So cos x comes out as 0.9568. And then in my calculator, I'm going to inverse cos and use the ants button. So the angle there comes out as 16.90 degrees. So now we have two sides and the angle between. So the area is a half AB sine C, or in this particular problem, it's a half BC sine A. A half multiplied by 20 multiplied by 11 multiplied by sine 16.9. So the area of that triangle is 31.981 square centimetres. Here's your question. Pause the video and have a go now. Here Here is the solution. So in this case here, I've decided to find the angle which is up here. And the area comes out as 9.92. Now you might have done this problem, got the same answer, got the correct answer, and your labellings would have been entirely different, or you would have found a different angle. It doesn't matter. All those methods are fine. Here's another problem. So this time, I'm given two sides and an angle, but the angle isn't between the two sides. So I can't use the formula straight away. So first I'm going to do is label. So I'm going to try and calculate one of these angles. So I'm going to be using the sine rule. The cosine rule we noticed from before. Going backwards. We would need all three sides. And the normal cosine rule is two sides and the angle between, which is just like the area. So for this problem I'm using the sine rule. So I've decided to find this angle up here, which is x. So I've done sine x divided by 5 is equal to sine 100 divided by 6. Multiplying through by 5, and then using the inverse sine, allows me to find x there. Now how does that help? Because again, we haven't got two sides and the angle between. But what we can do is find this angle here, where capital C is, and I'm just going to call that y. So the sum of the angles inside of a triangle are 180 degrees, which means y comes out as 24.85. In this case here, I've got two sides and the angle between. So I can use the formula straight away, which comes out as 6.30 square centimetres. Here is your problem. Pause the video and have a go now. Here's the solution. So in this case, I've decided to find this angle up here, which I'm calling x, and this one y. So sine x divided by 10 is equal to sine 50 divided by 8, multiplying through by 10, which gives me this numerator here. Then inverse sine both sides. So x is 73.25 degrees. Y would be 56.75. And then I've got two sides and the angle between. So the area is 33.45 square centimetres. Have a go at mini quiz 3 and come back to the video when you're ready. That concludes our lesson, and let's review the learning aims. The first one was to be able to calculate the area of a triangle, and the second one was to be able to apply different formulae to solve problems. That is the end of this lesson, and thank you very much for watching.